many of the things that we do with a little bit of spin hugely benefit the bottom line by cutting down costs, hugely benefiting the world by lowering emissions. I'm going to run this bad job whenever there's renewable. I'm going to turn off the lights and the APL, the access points of the ceiling automatically when there's no presence. Basic things that make a difference.
Hello, and welcome to Environment Variables, brought to you by the Green Software Foundation. In each episode, we discuss the latest news and events surrounding green software. On our show, you can expect candid conversations with top experts in their field who have a passion for how to reduce the greenhouse gas emissions of software. I'm your host, Chris Adams.
Hello and welcome to Environment Variables, where we bring you the latest news and updates from the world of sustainable software development. I'm your host, Anne Currie, and today we're joined by Carlos Pignataro, a leading voice in sustainable network architecture. Carlos has over 20 years of experience in technology innovation and strategic thinking, holding key roles at Cisco, including head of technology and data for Cisco's engineering sustainability. Currently, he's a mentor in residence at Duke University New Ventures, adjunct facility member at NC State University, and he is the founder and principal at Blue Fern Consulting. In this episode, we'll dive into Carlos's work on architecting networks for environmental sustainability. He's contributed to cutting-edge research on how networks, which are critical to our connected lives, can balance energy efficiency with performance and resilience. How can the networking industry innovate without compromising the planet? What trade-offs do we have to consider? Things like uptime, speed, against, or as well as environmental responsibility. Let's explore these questions and more with Carlos. So welcome, Carlos. Can you tell us a little bit about yourself?
Thank you very much. And I am so excited to be here, first of all. And I'm happy to tell you a little bit about myself, even though you covered a lot. That was a very kind intro. I appreciate it. My favorite number is 27. My favorite color is aquamarine, just for completeness. But on an equally serious note, important for my introduction is to say that I have passions for technology and for sustainability. And I look at tech as a means to an end, and making things better is one of the ends. I've been involved, as you mentioned, in building networks, computer networks, internet infrastructure, data centers. I have also been involved in other uses of technology, such as techno-conservation or conservation technologies, protecting endangered species, such as rhinos, in different countries in Africa or in India, from poaching using IoT, Internet of Things technology. I've been involved in building data models and information models for recycling and overall circularity. So I try to build my overall experiential breadth through trying different aspects of technology, and sustainability is one on which I'm super passionate about.
Excellent. That's very good to hear, and that's why you're here today. So just a little bit about myself, because I'm not always the host. I'm a guest host for Environment Variables. My name is Anne Currie. I've been in the tech industry for about 30 years. I am one of the co-authors of O'Reilly's new book, Building Green Software, which covers a lot of what Carlos and I will be talking about today, because there is a networking chapter in it. And I strongly recommend it to everybody who's listening to the podcast. I am also the CEO of learning and development company Strategically Green. We do a lot of workshops to help people push knowledge and engagement with green subjects within their own businesses. So touch me up on LinkedIn if you're interested in that kind of thing. So before we dive into today's content, is a reminder that everything we talk about today will be linked to in the show notes below. So feel free to have a look, read through, read as we go, read afterwards, whatever, but the data is all there. So let's kick off with an introductory question, Carlos. How did you become a Green Software Foundation champion? And what are your goals as a champion?
Thank you very much. And it's a very, very meaningful question. When I looked at Green Software Champion, when I was exposed to the acronym, to the three words actually, and the GSF acronym, I couldn't help but looking at each one of the words and understand that each one had a very, very profound meaning for me. Number one, green is something that encapsulates what you and your book and all of us are trying to push our industry and our different industries towards. Software is kernel of what we really do day in, day out, and our expertise where we can actually make a difference is where we live. And champion, I really always wanted to be a champion. And I try soccer, I try tennis. In Argentina, I have, which is where I come from, I have a very, very below average soccer score. Now, jokes aside, champion is such an important word because I look at it as the first followers, and I am very moved by the way in which we create a movement on what Derek Sivers describes into being the first follower. And having these champions are like reflectors. It seems this is a little bit on a working BGP reflectors of the message. So we all different have insertions in different parts of the ecosystem, whether it's within corporate, within different software Git repositories, whether it's different standard bodies. And being a champion means being a follower and reflector of that larger message and echo it within all the different places that we live. So it really aligns very, very deeply with my passions. And frankly, something that I see you, as I follow you as well, is like, I see the three words very, very clearly. And I don't know how you feel, Em, but to me, it's always a little bit of a work in progress. What we have achieved, I'll play that back to you a little bit, but as a question, but to me, it's like we have achieved a lot of awareness and we have achieved a lot of education and we have achieved the realization that there's a lot more and a lot more to actually do as a champion. I don't know.
I think you're very right there. We've done a lot. Things are a lot better than they were 10 years ago, vastly better. And I feel constantly buoyed up by that. But there's just so much to do still. I mean, still when I talk to most people outside of the immediate movement, folk don't realize that actually there is a lot of good stuff that the tech industry can do to cut carbon emissions. I speak to folk in tech all the time who are really interested in climate change and doing their bit. And they often focus directly on individual change they can make, like becoming a vegan or something like that, which is fine. But that's as nothing compared to the far more scalable change they can make through their jobs, through being a software engineer. There's an enormous change that we can make. There's an enormous improvement that we can make there. And it's nice when people realize, because folk do want to fix things. They do want to make a difference. And a lot of folk don't realize.
100%. It's so interesting as you were saying that. I was picturing myself the concept of bring your whole self to work, and the fact that we are individuals with a set of values and we can project them in different personas that we have. And for me, it was actually a part of my professional growth and realization earlier on as an engineer that I could actually bring my values to work as well. And exactly like you said, that's when the different really compounds. It's not like I have a nights and weekends green version. I can apply that in my day job, not only nights and weekends. And also what I find super monumental, and I applaud what you all do and what we do here, is there's so much more resources, so many more resources available for anyone who says, yeah, I want to learn and apply it.
Yeah. Yes. Oh, yeah. The number of resources is really taking off, which is amazing. I like what you're saying about bring your whole self to work. The good thing about building green software and being more carbon aware at work, if you are a tech company, is that, I mean, a lot of people feel, oh, well, it's a bit unprofessional because I'm bringing something to work and actually I'm asking the business to do something that is not in their best interest to do. When it comes to cutting carbon emissions, it is in the interests of the business to do that. It cuts costs. It makes the business more resilient. It makes it more future-proof to the way that the energy system is going. Eventually, folk are going to have to be ready to run on renewables because that is the new form of energy. I mean, people can do it in a way that is against the interests of the business. If you decide that you're going to rewrite all these systems in Rust, that might well be against the interests of your business. But cutting your energy use, cutting your carbon emissions in half by just being more clever and smart and modern about the way you operate systems so they're more efficient and more secure and more cost effective, that is in the best interest of your business. That's not going against it. And I think we do need to keep constantly hammering that message home.
Absolutely. It's a message in my corporate tenure within big tech. That's one of the key messages that resonated inside the company, resonated with customers, which is good for the world and good for the business. And finding these things, and that's one that actually I don't think is a marketing tag. I run numbers on, shall I do this? Does it make sense or not? And just like you say, many of the things that we do with a little bit of spin hugely benefit the bottom line by cutting down cost, hugely benefiting the world by lowering emissions. I'm going to run this bad job whenever there's renewable. I'm going to turn off the lights and the APL, the access points of the ceiling automatically when there's no presence. Basic things that make a difference.
Yeah. I mean, if you go back to I would say almost the inception of the modern thinking about being more efficient in data centers is the work that Google and Sun were doing at the beginning of this century around containers and orchestration, the use of that precursor to Kubernetes, their Borg orchestration system. That wasn't about cutting carbon emissions. That was about cutting the cost of operating systems and improving the resilience of operating systems. Those two things are completely aligned with carbon reductions. It's the way of being more efficient, being more resilient, being more adopting modern operational practices like auto-scaling, deliver all the things. Really
and
good.
I'll tell you one thing, if you don't mind, allow me extrapolate from what you're saying. The idea of actually having green software principles really as a inner workspace, visible and very aware, is so incredibly important, because the virtualization concept that you're talking about, Kubernetes and so on, are things that we apply to fight in the networking world, are things that we apply to any type of SFC, software function virtualization, NFVs, etc. And trying to bring a software more dynamic approach of how we think about it to things that are traditionally more, I have a big router and a big switch and a big antenna, softwareizing, if you will, the thinking, and doing that with the principles that you can have within things like that are at the reach of all of us, like some of the courses on green awareness. Building those principles into any type of software practice is such a win-win.
Yeah, absolutely. There's no reason for people to go, oh, I love the idea, but it's actually going to hurt my business. If it hurts your business, you're not doing it right. If you think it's going to hurt your business, don't do it that way. Do it in a way that is materially aligned with your business. That will scale better, will deliver more value, and you'll actually make it happen. So there is no reason why being green should hurt. If it does, probably doing it wrong. Stop.
1,000,000%. And I tell you, one of the things that we often think about, and I thought about very much in my CTO roles or when I do standardization, is how can we actually make some of these things codified, reusable, repeatable? Someone can actually learn, someone can actually use, whether it's a standard or whether it's a certification, and do that in the context of not only the architecting of software and networks, but also the operationalization of networks. One small example that I can share is work that we're doing with Alex Clem on sustainable network operations, which is an IEEE SIG or special interest group. And the interesting thing there is that when we look at the overall life cycle of networking and software, we have the use phase within the life cycle that focuses on the specific operations of network, operational aspects of networks. There's a lot to gain in terms of managing energy efficiency and carbon awareness and carbon efficiency. So how can, within our different insertion points within the life cycle, some are earlier, closer to manufacturing networking equipment or designing chips. Some are closer to doing architecting networks and actually designing networks and operations, and then plus networks, right? Like updating and upgrading equipment in a more circular, sustainable way. Each one of those areas has a very, very strong sustainable benefit that we can actually bring. These are the reasons, and honestly, and hearing you talk are the reasons why, going back to your early question, why I got really drawn into this green software champion concept.
It's interesting. I'm going to talk about something that you wouldn't necessarily be expecting at the moment. But one of the things that interests me, and we mention it a lot in building green software, is that networking is one of the few areas of the tech industry where there's already been a lot of thoughts which is directly aligned with energy saving. That networking has a concept of, is it bits per watt or watts per bit?
Yeah, and the interesting thing there is that there's been a lot of research and there's still ongoing discussion into how much things like energy over a number of throughput, like watts per bit or over megabit, how useful something like that is, because which I think is actually useful in many areas, and there's still an ongoing discussion about it in some standard groups, because if you take, for example, a core in a router, piece of equipment of the guts of the internet, and you have it powered up without traffic, that is consuming about 80% of the power.
Which is astonishing, isn't it?
It's crazy. And then with power, 95, right? So the proportionality has a smaller slope.
So actually, let's move on to some of our discussion points from today. So we're going to be talking about two papers that you were involved with and co-authored, contributed to. The first one is an article entitled Challenges and Opportunities in Management for Green Networking, which explores the environmental impacts of networking technology, noting that basically it says networking is great. There's loads of things come out of networking that can cut travel, that can significantly contribute to reducing carbon footprints. Networking is an amazing thing, but it also uses a lot of power. So if there's some way that we can get all the wins and reduce some of the losses and some of the waste, that would be fantastically good. But at the same time, we don't want to lose any of the wins. So do you want to talk a little bit about the article?
Absolutely. Thank you so much. I'm going to start, Anne, by honing into a couple of keywords that you mentioned, which are important in my mind. And the first one is the one about trade-offs. It's potentially tempting to say, I'm going to move a part of the system to another part which resides outside boundary conditions, and therefore things are more green. And it's one of the learnings that I've seen. I've worked in a number of technologies in my career, and sustainability, environmental sustainability, has been the more nuanced by far. We're looking at the system with broad boundary conditions. It's not like saying, I'm going to replace all the lights with LEDs, because we have material extraction to actually make the new light bulbs, and we have to dispose of the old ones. So if we look in the broader sense, we really have trade-offs. Imagine, to make it very practical, that we have a link between two routers, so two devices. If we add more links, we can have more redundancy. And if we add more routers to actually duplicate that and more links between them, we have even more redundancy. And that redundancy or resiliency improves asymptotically. It gets to a point in which I add more, and while my carbon emissions continue going up linearly, there's no benefit to redundancy. And in fact, the system can become a little bit more brittle. So one of the concepts that we kind of talked about a little bit, we have a multi-goal scenario. We are optimizing for two different goals at the same time, one of which is resiliency and performance and traditional business metrics, and the other one is for sustainability at the same time. So the main area where I feel that makes such a strong difference is in moving to automation. Moving a lot of these processes to automated processes is one in which we can actually get to an optimal point in sustainability while lowering the extra links for redundancy based on the needed traffic at the time, or the seasonality of the traffic, or the seasonality of the requirements. So that's one of the key pieces of that work. And let me explore, if you don't mind, another area of this paper, which I think is very, very relevant and important, which really is how we define terms. It's a Socrates quote that the beginning of wisdom starts with the definition of terms. And one of the things that I found is that in such a multidisciplinary field, in which you have people coming only from environmental sciences, people who are only tech, there's a little bit of an impedance mismatch sometimes in the dialogue. So even simple things like saying, for example, sustainable something versus something for sustainability, right? Do we have sustainable AI, meaning AI systems that are sustainable in themselves, and we call that the footprint, or AI systems that are AI for sustainability, meaning the output of the system can actually help you with sustainable outcomes, and we call that the handprint, right? So the concept of footprint and handprint are not necessarily well understood within the networking and software spaces, in my experience.
Yeah.
And I feel they're fundamental. You want to reduce the footprint, you want to improve or enhance or grow the handprint.
Yeah. I agree. It's not a well-known phraseology. We use this in building green software. It is a bit counterintuitive in that kind of like footprint bad, handprint good. But it's like, why is the foot so bad? If you're judging by your the reverse of the football analogy, where hand is bad, foot is good. But in green software, we talk about footprint, foot being bad, and handprint, hand being good.
That's right. In football, you would get a red card, and in green software, you're gonna get a green card.
Indeed, yeah. Indeed. But I don't terminology, because I think it's a tad confusing, but it is well known. And that's what we're talking about here, which is fine.
Thank you. No, for sure. And I'm gonna bring back also something that you said before, which is the networking industry have been thinking for quite some time in many sustainability aspects, and at different levels. At the chip level, as I was mentioning, at the power efficiency, there's metrics. You cannot improve what you cannot measure, trackers. So we have power efficiency for data centers and so on. And that becomes much more and more important, because the amount of electricity that gets consumed by networks, and particularly data centers these days, keeps growing and keeps growing. There's many things that we can learn from the way in which we design protocols. Part of the work that I've done historically is protocol design within the Internet Engineering Task Force, the IETF, writing RFCs and things like that. And there's very interesting work on protocols for the Internet of Things. And that is interesting. And because IoT, Internet of Things devices, just by their use case, need to minimize power consumption, need to be alive for years and years and years on battery power. So protocol definitions evolve so that protocols are a lot less chatty. There's a lot less back and forth and wake up. Devices can actually go to different levels of sleep. The same way that we have sleep levels in the laptops that we're using, you and I, right now, and on the phones, on the handhelds that we have, there's less of that in some of the networking areas. And that is an active area of research and development, how to bring dormant states, less chatty protocols into some of the networking arena.
That is something that I really liked in this paper. So stepping back for a minute, there's the IETF and the IRTF, which are both parts of the same organization. The IETF tends to focus on protocols, designing protocols, but it actually, and the way it does that is it talks about a famous definition of how it approaches things, which is rough consensus working code. which is based on the fact that actually it's very hard to tell what's going to work in networking because it's so complicated until you actually get something out there and see whether it works or not. An IRTF, which is a lot of what these papers are, is about kind of research and thinking. But it's hard to marry those two things, I would imagine, in many ways, because the whole point is that you can't necessarily just think through which network protocols are going to work and which are not. You almost have to suck it and say. But one of the things that you pointed out in your paper, which I liked, was there are already protocols out there that are working, that are achieving what we want to achieve here. There are already protocols for Internet of Things which are out there working. And it would be great if people looked at them and said, what works there and what doesn't work there? How can we apply that learning in other environments? I think that's what you're saying.
1,000,000%. That is actually in a much more eloquent way with a couple of the very important points that we try to convey in the paper. Thank you very much, Anne, for explaining IRTF, IETF, I-STAR. I wasn't sure if we wanted how boring that was, but it was actually very useful. So you put both up in context.
Well, what I quite like to do all the time when we're doing it, what we know works in terms of delivering good stuff in human history is to look at stuff that works in a similar but not identical field and say, let's steal some of those ideas. And something else I liked in your papers was when you talked about CDNs and the ideas in CDNs, content delivery networks, if people aren't familiar with them. They are what I think one of the most interesting architectural approaches in networking and in technology above the network as well. And there are tons of ideas there that feel that they could be borrowed. And you said the same thing in your paper. What's your thinking on CDNs?
Yeah, no, it's exactly that. Thank you for it, because the main point is exactly that. There's many areas that there's already been deployment, not only research and not only development and not only test and Q&A, but deployment that can be applied to new things that we need to do today, right? So spot on that, IoT is one of them. And because naturally, there's not necessarily a very smooth bridge in my experience between research and standardization and actual deployment and running code is a little bit bumpy. So having examples and use cases that work, that we can apply to the problems between code that we have today is critical. When we look at the most dynamic and complex networks, I really look at CDNs because it's a network that is actually focused on delivering the content. And in a CDN, it's incredibly critical to, number one, replicate content near the receiver, right? So that you don't have to stream from transatlantic, but don't over-replicate if there's not a lot of listeners and receivers. So the equations can really, really help you to minimize the overall end-to-end system electricity consumption and maximize efficiency just because of what to replicate, where to replicate it, at what times do we do this when we have a signal that the electricity feed that we have is coming from renewables. It's one of the systems that really gives you the flexibility to implement all of the things that we discuss in a paper. And if you allow me again to extrapolate a little bit more, I frankly think that talking about green and talking about sustainability, we can actually extrapolate further and look more into what nature does and try to understand and replicate that in some of our systems. The fact that our laptops hibernate, first there were animals that's where they come from during the winter. They were saving mode, right? It was a bear in saving mode, and we have a laptop in saving mode. And next we're going to have a data center cluster in saving mode potentially. And many, many ways in which if we look at the amount of energy that our brain uses versus an LLM system uses, there's clearly a huge, ginormous opportunity for improvement.
Yeah, that's true. But yes, actually, it's interesting that you mention LLMs and AI there, although not directly. But I'm very interested in networking and LLMs and how those are going to be merged together in a green way. As I said, I'm a huge fan of CDNs. So as you said, CDNs use buffering effectively close to users to do two things. To mean that every time if you've got somebody in London and they want to look at a huge asset that was served from the US, maybe an episode of Game of Thrones. I still use Game of Thrones, even though it's a bit out of date. It's better to have that episode, one copy of that episode, move over the Atlantic and be cached somewhere local to the user in the UK, and then all the users there just take it over a shorter distance rather than have to take it all the way from the US, as you said. There's another benefit, which is that you can move that giant asset at times when the internet is not busy. So it flattens. Something you've said in your papers, you talked a lot about, was the efficiency of flattening peaks in load, peaks in demand. It's much better if you could spread demand, find some clever way of spreading demand out so that you don't have peaks that you have to provision for, because that means you need more equipment and more of everything. It's not as resilient and it's more expensive. So CDNs are fantastic from that perspective, but AI feels like it could potentially benefit. AI inference feels like it could potentially benefit from CDNs as well. If you could try and cache responses that are common questions so that you weren't having to run everything. Sorry, I'm taking you off networking now. I don't know if you had any thoughts about AI and networking and CDNs or anything like that.
I work a lot on AI these days, and I definitely have thoughts. I think, number one, and thank you for the bunny trail towards where the dialogue takes us and things are relevant, right? The way in which we actually train systems today can immensely be improved, and whether that's by some mechanism of incremental caching so that you don't have to relearn everything as you actually tweak the model and things like that, CDN-like. Absolutely. And another way in which I really think about it, and frankly, particularly with a couple of startups that I'm either working on or following or seeing, is do we want the typical Army Swiss knife, B2C, business to consumer, that can actually solve everything and we need 3 cities worth of electricity to train? Or do we define more constrained SLMs instead of LLMs, small language models that are a lot more domain specific and a lot more domain shifted and more B2B potentially, business to business type? And regardless, I think that going back to sustainable X versus X for sustainability, I always like to do 2x2s or XYs. Mm-hmm. And I think that AI as a broad technology from machine learning and computer vision, and has moved significantly into going AI for sustainability. We have Google Maps today that can actually give me the most sustainable travel, fuel efficient route, and I go in to book my flights and I see carbons of each one of those. And there's a lot of AI that is applied for sustainability. There has not been enough, or I should say there's an enormous upside and opportunity for sustainable AI, mm-hmm. right? So in the backwards lingo that we were using, a lot of handprint, not enough reduction of footprint. And I think a lot of methods that we know from other domains, like CDNs, that we can apply to inference and learning of models. Absolutely. Please, let's do.
Mm. Yes. I mean, in many ways, it feels like it is the lesson to take away from the internet, which is that it's really hard to make things work. You have to, like Rufkin said, working code. Working code absolutely is the king. So if you can take someone else's working code and apply it in your situation, that's a great idea.
Exactly. 1,000,000%. And one thing, and that I'm going to mention now, because I fear that the way in which we're choosing conversational forking paths, I'm going to forget. So because it's important. It's a call to action. And one of the things that I mentioned is how much more resources and material exist. And really my call to action is to go to learn.greensoftware.foundation and start with the Green Software Practitioner curricula. Is such an incredibly well-packaged set of modules that go through a lot of the fundamentals and demystifies. It provides lexicon, it demystifies, it talks about carbon. And one of the important ways in which I want to make this actionable is to really encourage any listener it's super easy, learn.greensoftware.foundation.
Excellent. I totally second that. And I apologize, Carlos, we have gone all over the place on our discussion today. So you're quite right to stop me and make sure that's a very important message got through. So, I mean, we are now coming towards the end of it. Is there anything else you want to tell you? There's tons of interesting stuff in your two papers that are well worth folk reading. You don't have to feel that it's too difficult. The papers are quite accessible. Is there anything that we haven't talked about that you would like to talk about?
Thank you. And first of all, thank you for actually reading the papers and actually not only reading, but really reading, because you actually distilled some of the fundamental principles that we and I wanted to convey. More than anything, what's needed to drive green software is our full commitment and bringing, like you were talking about, like I was mentioning, our values and whole selves to the way in which we code and the way in which we do finger to keyboard. This is a very multidisciplinary, nuanced area. And after leading in Cisco technology and data for the engineering sustainability team, we really don't know what we don't know. And for me, learning and staying humble in every conversation is fundamental. One of the things that I love about the approach that the GSF is taking with SCI is that it's data-driven, right? Let's get metrics, let the data as opposed to myths drive the conversation, and to continue to stay together, because the ecosystem is multidisciplinary and we all learn a little bit from each other, and reusing and leveraging particularly code and principles that you talk so very well in your book. And those principles, that code, bring it in our insertion points within the ecosystem, whether it's at the vendor or if we're cloning in a public repository and making some changes, or if we're thinking about the next networking protocol or networking operations.
Yes, very true. So I think that's a very good place to be finishing up, because we've pretty much come to the end of our episode. And I have one final question for you, which is, where can listeners go to if they want to find out more about you? I mean, obviously, links to the papers will be in the show notes, so I strongly recommend you to read them. But where else can people find out about you?
Hey, thank you very much. And LinkedIn is an easy place to go, and I'm always open to any connection and any messages. My website, you can check out also bluefern.consulting, and has my email, has my contact. I don't just say that. Like you, and you respond, I respond. So super happy to continue the conversation and continue engaging.
Excellent. That's very good to hear. I'm sure that lots of our listeners will reach out and talk to you, but certainly they should be reading your papers and they should be connecting to you on LinkedIn or looking at your LinkedIn, following you on LinkedIn. And so thank you very much for being on this episode. It's been a fascinating episode, a deep dive into networking and all the... Networking is not... It's been very interesting because a lot of the concepts also apply to non-networking software. All the ideas and the overlap in CDNs, which really are the concept, I think, that's best suited to environmental sustainability and aligning with renewable power in the long run. And a final reminder to all our listeners that the resources for this episode are in the show description below. And you can visit podcast.greensoftware.foundation to listen to more episodes of Environment Variables. So see you all soon. Bye for now.
Hey everyone, thanks for listening. Just a reminder to follow Environment Variables on Apple Podcasts, Spotify, Google Podcasts, or wherever you get your podcasts. And please do leave a rating and review if you like what we're doing. It helps other people discover the show. And of course, we'd love to have more listeners. To find out more about the Green Software Foundation, please visit greensoftware.foundation. That's greensoftware.foundation in any browser. Thanks again, and see you in the next episode.